Okay, so yes, I may be in between 1, 2, 3, 4, 5, 6, 7 different projects at the moment, but I just got a new thing in the mail, and this is way more exciting than anything else I've got going on. So on today's episode of Mellow Labs, I'm turning my TS100 soldering iron to be USB-C compatible. This episode is brought to you by JLC PCB, your one-stop shop for your electrical and mechanical project needs. JLC PCB offers services such as 3D printing, CNC milling, and of course, PCB prototyping and component sourcing, so everything you need to get your project going is available on JLC PCB. And their website is super easy to use. Simply head over to JLC PCB, select which service you'd like to use, and drag and drop your design files and get an instant quote. And don't forget to use the code MELLOWLABS at checkout. You can get professional prototype PCB boards for as little as $2. And right now, JLC PCB is offering a $30 coupon on their 6-layer PCBs. So you can get a high quality, multi-layer PCB starting from just $5. Thank you again to JLC PCB for sponsoring this episode. Check out the link in the description for more information. Let's start with all of the research I've done for this project. Number one, I saw this Hackaday post, then I went over to the original person who made it, and then I looked at this image and I went, okay, so I need a USB-C power delivery module. I looked it up on eBay and there's a couple different ones. There's some with like dip switches that you can adjust the voltage of and stuff. I think this is actually for battery power, so that's a little bit different. But there's some with dip switches that you can adjust. There's some with resistors that you can adjust the voltage of, or you can just get them like preset to 20 volts, which is what I did. So I ordered these and now I have them. So now let's put one of these in my soldering iron. Right, let's move most of this aside apart from that because I'll need it. That's for a later project. This is just a USB-C hub. It's a very fancy one because it shows you how much power things are using. I don't know how accurate it is, but we'll find out. To begin with, let's see if these 20 volt modules are actually 20 volt. I probably don't actually need 5 of them, but they came as a set of 5 and I might be able to USB-C-fy other things in the future. If I plug this in here and plug that in here, it does nothing. Okay, maybe it needs a load. Let's put a multimeter on it. Okay, so this is a little strange. The multimeter says 20 volts. This says nothing. Like nothing at all. What if I move it to a different one? No, still nothing. Maybe it's just because it's not drawing any actual power. Let's hook it up to something. Okay, so I have this 20 volt fan from a previous live stream disassembly. I'm gonna solder it to this module and see if it kicks on. Stop moving. Let's see if we get anything. Ooh, we do. So it's correctly reading 20 volts at 0.2 amps and a whopping 4 watts of power. Awesome. So now that I know that it works, ow, I can put it in the soldering iron. I got a boo-boo. Ow. Now, the real question is, do I even need this modification? For 99% of the things I do, I have my soldering iron station at my desk where I do most of the soldering, but sometimes I need to go somewhere or be in a tight area and I want to bring my soldering iron, but the fact that this uses a barrel jack means I have to bring a power supply just for the soldering iron. It would be a lot easier if I could just bring my laptop power supply, because I have to take my laptop with me anyway. And yes, I realized I could just go out and buy myself a new soldering iron with a USB-C port already installed, but that involves me spending money. And I don't want to do that. So that's why I'm modifying it. Now, I've had this soldering iron for a few years now, and it's starting to show its age. I've got a missing screw here. This part is broken, and this no longer really holds on, which makes it the perfect test subject for this modification. I think the only thing holding it together is this one screw here. I was correct. Right, let's pop this out. How do I pop this out? Oh, another screw. Oh, there's tiny screws here as well. Cool. First order of business is to desolder this barrel jack connector. Okay, so let me just go over my thought process here because it goes downhill very quickly. So I tried desoldering it the same way I normally would, with my soldering iron, a little bit of new solder, and then sucking it up with the solder sucker, and that worked a little bit, but it was still holding on. So I tried some solder wick just to like wick off some of the remaining solder, but that didn't really work. So then I thought to myself, well, I don't really need this barrel jack connector anymore. I grabbed my snips and tried snipping at it, and that didn't really release it. And then I got a little bit frustrated and I tried cutting it off with my Dremel, and that did not work very well as well. And then I decided to use the hot air station, and I'll just let him take it from there again.
Okay.
Well, there's a pro tip for you. Use a hot air station instead of trying to do it by hand or Dremel. I realize I may have slightly Dremeled the board. Oops. Let's clean this up a little. I do now realize I did not check the polarity of the jack. I assume the inside is positive and the outside is negative, but I have no way of knowing. Let's power it with my power supply to confirm. I'm gonna set it to like 5 volts and see if the screen pops up. Okay, but no power going in. What did I break? Oh, I removed the part and I'm wondering why it's not working. Right, let's plug that back in and hopefully now it turns on. Still nada. Okay, maybe if I turn up the voltage. I'm on 5 volts. Hopefully. Oh! Okay, 8.3. It kicks on. Okay, well, at least now we know the minimum voltage. And it still works. Awesome. Now let's do the USB-C. Right, so I'm thinking I'll put some tape on the bottom of this, put it there, I'll do the ground connection there, and then I'll run a wire for the thing, and that should be good. I'm gonna file this PCB down a little bit because it's got a sharp thing there, but also I think I can get it just a little bit smaller. Okay, so now I'm gonna solder on a wire through the positive and the negative and then run it down here. Right, let's move this out the way for a second. Put this in the vise. Okay, so this is what I have. Just a couple wires attached to the board, and hopefully I now put this board here like that. And I should be able to just poke the ground wire through there like that. Oh, I need the in-between thing. Okay, we have some electrical tape. I think I'm just gonna lay it down on here actually. It'll be easier for me. Okay, so I tried getting the PCB board of this to end with the PCB board on this, just to keep it like consistent length, and hopefully I've got it. So I'm gonna solder these down how I've got them right now. I am a little bit worried because there's not a whole lot holding the USB-C port in place, or the whole board I mean, which probably means it's going to rip out at some point. So I might see if I can do something about that after I've confirmed that it works. Okay, let's snip this guy off and snip this guy off. Can wiggle it, but it's not too bad. Right, let's power it and see if it does the boot. USB-C into the soldering iron and USB-C into the port. Okay, we've got power. Let's see, we don't have a tool, that's okay. Power settings, temperature, that's boost, that's not what I want. I don't want to be in settings. I don't think it's gonna let me check voltages and stuff until I've got the actual heater bit in place. So let's try putting it back together. Okay, it's like a little bit too thick. No, actually no. No, I lie, it fits. It does push out the plastic a little bit. Let's see what we can do about that. Okay, small disclosure, PCBs are made out of fiberglass. So when sanding, wear protection. You don't need to do it this way, I'm just me, and I like doing things the hard way. Turn on. Hopefully that's all I need. Let's try to put it in the case again. Ooh, it fits. It's not ugly. Okay, now the actual case is in the way, so let's do that. I'm not too worried about roughing up this case, mostly because it's already broken. And also, I've seen there are some 3D printable variants out there, so if this goes really badly, I can just print myself another one. It slides in here, like so, and it fits perfectly. Beautiful. Okay, let's screw it back together. Oh, I forgot to put the buttons in. Damn it. I have big fingers. I don't like working on small things. Okay, I think that's all done, so I should be able to put the back on now. Yes. Look at that. That looks somewhat good. If it wasn't that, if the plastic bit wasn't broken, it actually would look good. Okay, well, the other USB port is a little bit crooked, but I don't think I had anything to do with that. Well, I guess that just leaves testing it out. And right, turn that on, plug it in. Screen. It's going up. It's sucking up 10 watts at 56 watts. Nice. Okay. It works. Sorry, my voice cracked. It works. I have no words. I made a thing work. I definitely need a nicer cable. This one's very rigid, but apart from that, this actually works. Sweet. Well, that was actually a super quick and useful modification. I'm not super confident in this because it does like to move around a bit. Honestly, I think I'm actually just gonna leave it. In the future, if it becomes a problem, I'll just resolder it and like do something about it. But for now, this is gonna work fine. So with that, thank you very much for watching. Don't forget to like and subscribe. Check out the links in the description. And if you enjoy what I do here, please support me over on Patreon. And I'll see you on next week's live stream where I will be using this soldering iron. Goodbye. It works!